Okay, so we know what a mixed number is now, right? For example, we know when we have a whole number with a fraction, this is called a mixed number. We can get mixed numbers from improper fractions, right? If we had the improper fraction, let's do a super easy one. If we had 3 halves, we know if we were to quickly draw this out, right? To get 3 halves, I would have 1 whole and 1/2 left, okay? But now we're gonna start to see when we have to add and subtract these mixed numbers. So we might get something that looks like this. 4 and 2/5 plus 2 and 1/5. Okay, we just need to know what we need to start with and where we need to end. What I like to remember is when we're talking about fractions, right? When we're talking about the fraction portion of a mixed number, it's very similar and can be equal to like a decimal, right? For example, if we had 1 and 1/2, this is the, or sorry, 4 and 1/2, I don't even know where that came from. This is the same thing as 4.5, right? This right here is a half. So when we have mixed numbers, what I want you to be doing is I want you to write them on top of each other, okay? So kind of like when we have bigger numbers in addition, I'm gonna just show you this really fast, right? If we have 235 plus 543, right? How we go about solving this is we would write them like this, right? And this makes it super easy for us because now we can see, okay, here's my ones place value, right? 5 1s plus 3 1s is how many ones? Show me with your fingers. Nice, it's 8 1s total, okay? Then I move over to my tens place, right? I have 3 10s plus 4 10s. How many tens is that total? Good job, 7 10s. And then finally, I'm ending at my hundreds place. I have 200s and 500s. How many hundreds do I have total? Nice job, 700s, okay? We can look at mixed numbers as sort of the same thing. So my original problem that I had was 4 and 2/5 plus 2 and 1/5, okay? If we think of these as place values, right, here is what we're gonna call for right now our fraction place value. It's really our tenth, right? And then over here, we have our ones place value, okay? So we're gonna start over here with our fractions first. Is 2/5 plus 1/5 very easy for us to do? Okay, how many fifths would I have total? If I have 2/5 plus 1/5, show me with your fingers, how many fifths would I have total? Nice job. I would have 3/5 total. Okay, so I already did this part. I'm good to go. I already have my answer down here for that. But now I'm gonna move over to here. 4 1s plus 2 1s. How many ones is that? Show me with your fingers. Nice job. I have 6 1s total. So if I look back at my original problem, 4 and 2/5 plus 2 and 1/5 is equal to 6 and 3/5. And we're going to prove this right now by drawing it out, okay? So I'm going to keep my screen blank, but kind of keep this in your mind right now. We originally had, I'll write the problem really small over here, 4 and 2/5 plus 2 and 1/5. So let's draw this out. First, I'm going to start with drawing out 4 and 2/5. Okay, so I know I'm going to have at least 4 wholes already because that's what it's telling me right here with my 4. But I know I'm going to have some left over, which is going to be my 2/5. Okay, my denominator tells me how many parts is my whole being broken up into. Nice job. So right here is my denominator. So I'm being broken up into fifths. Here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Finally, 1, 2, 3, 4, 5. Does everyone see how I broke them up into fifths? Okay, how many holes are going to be completely filled up? Nice job, right? I have 4 holes already completely filled up. So here's 1, 2, 3, 4. That's where this 4 is coming from right here. Okay, how much am I going to have left over? Casey, how much am I going to have left over?
2/5.
2/5. So over here, my last one, I need to shade just 2 of them. Okay, we're adding this to 2 and 1/5. So let's draw this one out. 1, 2, and then I know I'm going to have some left over. I'm breaking these up into fifths as well because that's what my denominator is telling me. Okay, show me with your fingers how many holes are going to be shaded in. Good job. 2 holes are being shaded in. Here's 1 and here's 2. And how much is left over that I need to shade in? Kyler, how much is left over that I need to shade in?
One more. 1/5 more.
1/5 more. Thank you for clarifying. Okay, so let's count up. How many holes do I have total now? And how many are left over? Here's 1. Let me make this bigger. Here's 1 hole, 2 holes, 3 holes, 4 holes, 5 holes, and 6 holes. Thumbs up if you agree. Those are the only 6 that I shaded in the entire thing. Okay, so I have 6 holes. Okay, well, how many fifths do I have left over now? Here's 1, 2, and 3. I have 3/5 left over. Thumbs up if you see how I got that answer. Okay, you don't need to draw it out every single time. I just wanted to prove to you guys that's exactly what we're doing when we do this stacked form, right? When we had it stacked up like this, what we're doing is we're adding these up together to get 3/5, and then we go over to our ones place, which we know is 6. Okay, so I'm going to give you guys one to try on your own. That's kind of simple to start off with. Okay, so let's do 2 and 1/4 plus 5 and 1/4. Okay, solve on your own. Remember, write them in stacked form first. Okay, perfect. Okay, so I want you guys to now take this problem. Remember, we're working from right to left. So look at what your place values are right now and see what you end up getting. Okay, take a second to do that. And thumbs up once you have an answer. Okay, let's first start and look at 3/8 plus 7/8. When I have 3/8 and I add 7/8, How many eighths do I get total from that? Maria, how many eighths do I get total from that? If I have 3/8 and I add 7/8, how many eighths total are there?
10/8.
10/8. Great job, Maria, right? 7 plus 3 is 10. We're talking about eighths right now. Okay. Now let's move over to our next place value. We have 5 ones plus 2 ones. Emma, how many ones do I have total when I do 5 ones plus 2 ones?
7.
Good job, 7 ones. Okay, now I want you to look at what we got as our answer. We got 7 and 10/8. What are we noticing about this answer that we need to change? Our answer is correct, right? But we just want to be writing it a different way because there's something about our answer that is, I'll give you a hint, improper. What about our answer is not the way we should be writing fractions? Let's try with Leah now. Leah, what are you noticing about this fraction?
So that 10/8 is improper.
10/8 is improper. You're absolutely correct. This is improper. So what we actually end up needing to do is we kind of have to do a little bit of regrouping here. So remember, oh, I wish there was a way I could like save this screen and go back to it. But we have this fraction right now, and I'll write this up here. We have 7 and 10/8. Okay, very similar to if we had, let's say, 21 plus 19, right? This is very simple for us now, right? 1 plus 9 is what, class? Just show me with your fingers. It's 10, right? But do I write my 10 just like that? No, I have to regroup it. So my 0 goes down here, and I now have 1 10 that I can move over. Is this ringing a bell? Same thing with up here. We technically, when we have 7 and 10/8, we have enough to regroup into another whole, right? Because 10/8, who knows what is 10/8 as a mixed number? What is 10/8 as a mixed number? Tanush, what is 10/8 as a mixed number?
1 and 2/8.
1 and 2/8. Great job. So technically, if we were to break this apart as 1 and 2/8, we can just add our 7 plus 1 plus 2/8, which gives us a total of 8 and 2/8. Do we have an improper fraction up here, or are we good to go? We're good to go, right? We have no improper fractions. We only have whole numbers, and we are good to go.